Hello everybody. Thank you for selecting this video. I hope you will enjoy the subject that I have presented to you today. The first presentation of this idea of a character slice index happened in June 2008, which is quite some time back. It was a reaction on the fact that with the introduction of bitmaps and a bit slice index, there was the idea that we can slice numbers into bits, index it, and calculate it. And the question that came up was, why can't we do this also for characters? Taking some characters somewhere in the text and looking for them in a fast mode. Well, cutting numbers into bits is a rather natural exercise. Bits and numbers are quite close to each other. Cutting strings into characters seems a little bit more tricky, since the related structures are all word-oriented. But this is limited to Western languages and not but total natural for Japanese and Chinese language, where a single character is a word. And this was the idea to go along and try a different approach. The solution is there is a data type text, %text, which is an extension to a normal string, and the text is related to a language pattern that defines how words are organized. And it's all about words. That's the important point. You have a data type, you have as it is a string, you have a maxlang, and you have a language class. And that language class is the one that defines how to split your text into words. And then you can create an index on the document of type bitmap and do a very fast search for the words. For characters, you have to go a step further and think about Japanese or Chinese that expresses a verb with a single character. And now I started to mix it up, took the example from those languages that were available already, and now got an index of any character, any punctuation on your large text. The key to do the split and the separation is the dictionary. The dictionary class is just a collection of parameters. And the most important parameter is separate words, and the word size is 1. Okay, and now you can go along, apply this to your text, even if it's not Japanese, and you get characters instead. So let's take a look what happens Now, as Humphrey Bogart said, let me look into your eyes. No, let me look into your characters to index them. Now I go to run the demo. The Docker container is already installed, is up and running. I entered the command line, started the SQL shell over the alias, and now we go to populate our test data. We have the first piece, and let's do another. It's just a standard populate exercise, and let's take a little bit larger. So, and this is enough data for the moment. In the next step we see what this means from management portal. Now we go to system management portal and take a look to our test data, which is well, the typical lorem ipsum type of text with variable length, with 50 characters, shorter ones, just as we generated it. And probably more interesting, a look to the index globers. We have, of course, first an internal line index, which is a bitmap, but the more interesting one is the slice part of the index. And if you take a closer look, you see there are already characters grouped. We have defined single, double, three groups of 3 for our search exercise, and you see that is a looks real typical bitmap type of index globers. A jump to the SQL section is more interesting. First we do a classic search for line contains. We execute it. We have 4 hits, and we see there are 491 global references and quite a bunch of commands to be, some 5,000 commands to be executed. Now we go to compare this to a character slice. For the character slice index, there is not much change, except that we have this function contains term that forces the use of the index. We execute it, and you see already with this rather small exercise we have used just 75% and also less commands, less global references, less commands. That's not yet so dramatic, so we take another exercise. This exercise now looks not just for one combination, but also for another combination. the UL and the W. And if we execute this, you see 4 hits, and you see it takes longer and takes much more global references as before. Probably a little bit less commands, if I remember right. And now, once again, the cross-check with the character slice index. You see the typical contains term, and we're just looking for 2 values within a run. And again, you see a dramatic reduction of global references and executed commands. Well, this may not look so dramatic here, but overall, we run our count, and well, this difference that you saw happens on a very, very tiny sample of just 158 records. And already there you see the difference. So you might imagine, and that's not necessary to have a lot of fantasy, that the impact is, of course, on very large datasets where you have large text, a lot of possible combinations, and especially there is no need to have full words. You just go for characters. If it's a single character or 2 characters, 3 characters, it depends on the dictionary how large your index is, but the effect is dramatic. Well, and I hope you find this exercise and look into some ancient technology that is existing for quite a while here and rather unknown, a little bit interesting, and you liked the presentation. Okay, this was the video. I hope you enjoyed it. I hope it was interesting to you, and I hope you will see me again with my next video on this channel. Goodbye.